We move on to question 6. Question 6 reads as follows. Two players play a game on a 1 by n strip of squares. It means one row and n columns. Initially, the first player has a counter on the leftmost square, and the second player has a counter on the rightmost square. So let's just record that. So there was something like this, and there are many squares here, but at the starting point, this one player has got a counter. Yeah, let's call him A, and the other guy has got a counter at that spot. They take turns to move their counter. A player can move his counter either one square to the left, like this guy, or one square to the right. So they can go either way. If a player can't make a move, the player loses. So obviously that will happen when one player pushes the other guy to the end of this line. All right. If both players play optimally on a 1 by 4 strip, of squares, which player always wins? So if you play on a 1 by 4 strip, which player always wins? 1 by 5 and 1 by n. Yeah, I'm going to do the general one, n by n, 1 by n, and solve the problem there. And these two will just become applications of that more general problem. Okay, so we are going to assume that the that the grid is a 1 by n grid. Okay. So here we go. We've got n squares here. If you just think now, let's take the 1 by 4 case, which they identified. I thought I can skip this, but that will be quite illustrative. So you've got a player, let's call this player the first F. He plays first. So he plays first. So he is here now. And this guy then follows. Let's give him another color. So he plays. Now it's this guy's turn to play. He has to move backwards. And this guy moves forwards. This guy can't play at all. So in this case, first loses. All right. So let's go to the 1 by 5 case. which they asked you to solve anyway. We'll see what happens here. Right, so the first player will make his move. And the second player, he plays here. Okay, let's do that. Then the first player plays here. Now you can see the second player is now shoved to the back. So for n equals 4, first player loses. N equals 5, first player wins. So it seems to me that when n is odd, when n is even, the first player will lose. And when n is odd, the first player wins. Now, how do we argue this? Remember, they can move backwards or forwards at any time. All right, so I've got 3 diagrams here. This is, let's say, when n is odd. There are n squares here. The first player is here at the start of the game. Okay. Now, we consider what happens after every 2 moves. After every 2 moves, okay, before we go on, it will be quite clear that the player who wins, right, they will be in a situation like this where they are face to face, and the player whose turn it is to play at the spot will lose because that guy will have to move backwards and the other guy will just keep pushing him. So the player who is first to play at this spot here, he will lose. Right. So now the number of spaces between the two, if n is odd, after every 2 moves, so this guy will move and this guy will move. This is the first player. Now it's this guy's turn to play. After every 2 moves, the number of squares between the players either, okay, after every 2 moves, okay, at the starting point, you see that the number of squares decreases by 2. Because he's taken 1 square, he's taken 1 square, and there were originally the number of squares is now 2 less. Originally there were the number of squares between them has now been reduced by 2. Okay. Now you could have a situation like this. This is the case where both move towards each other. Now you could have a situation where this fellow moves and this guy decides to move backwards. Right? So because they can move forwards or backwards. They come up to a certain place and this guy decides to move backwards. Then what happens is that there's no change. the number of squares between the two players, there is no change. The distance between them is still the same. And then you could have that both move backwards. Right? After after every two moves, they both move backwards. Then in this case, it increases by 2. Increases by 2. So the point is, if n is odd, you will see that the number of squares always number of squares between the players is starting off with odd. If you decrease or no change or increase, the oddness remains, is always odd. Right? Because you're starting off with an odd number, and then that either decreases. At the starting point, the odd, these two people are at the two ends, they're using up two spaces. So at the starting point, the number of squares between them is n minus 2, and that is still odd. And after every two moves, it just continues to remain odd. So what happens is that there comes a time when there will be only one square between them. When this is 1. Because it's always odd, and they can move towards each other. You see, the one fellow will carry on going forward. The other guy can do whatever he likes, but the guy who goes forward will be the second player. When he goes there, the second player comes there. Now it's this guy's turn, the first player's turn. So there comes a time when the first player's turn, he sees that there is only one square there between them. He has to go into that, right? And then the second player now has to recede. So in this case here, the first player wins. I'm just trying to think now in the 5 case, the first player is there, the second player is here, the first player goes here. That's right. So the first player goes here, the second player loses. So in this case, the first player wins. So when n is odd, f wins. Now, so what happens when n is even now? So when n is even, the same argument says that there will come a time or otherwise you can say, see, when n is even, then as soon as the first player plays his first move, right, then the second player n is even, right? So you've got 1, 2, 3. 1, 2, 3 squares. So the number of squares between them, if you started off with n is even, then the number of squares between them is n minus 3 after the first player moves, right? So now, in this case here, we see that the first player wins. Namely, now this guy is now starts to play. It's his turn, and he's got an odd number of, n is even. You see, this is odd. So as far as this guy is concerned, he now has an odd number of squares between them. So we said earlier on that the fellow who has got an odd number of squares between them will win. So here the second player wins. And we saw that in the case when there were four. First player, the second player. And now they are together head to head. So the first player will have to concede. So that's the general formula. When n is odd, the first player wins. When n is even, the second player wins. All right, it's a nice problem. They have many problems like this, which are what they call game problems. And there's no mathematics, not much mathematics here. Okay, let me just show you the solution which I wrote. Yeah, you can read this to get a better idea as to what I've just said. Okay, let's get on to this next question. Question 7. It's a geometry question. Two circles of radius 1 and centers C and D intersect at a point A. BD is the diameter of the circle with center C. I don't know why I've got so much of spaces here. All right, so these are the centers now of the two circles. So what does it mean? It means that, okay, so you got this diagram drawn, and the question is, what is the area? What is the size of angle ABC? This angle here. Right, what is the size of that? Okay, let's just fill in the radii. And when you take C and join it to A, what happened here now? Right, okay. When you join it to A, let's just join all these. Okay, you'll notice they say that both the circles have got radius 1. So this is the center. So all these are 1. This is a radius, and this is a radius for this circle. But both circles have got radius 1. So you've got an equilateral triangle here, and all the sides are 1. Okay? And here, even this is the radius, because this is the center. Whenever you join a center of a circle to a point on the circumference, you'll get the distance to the radius. That's what we are using here all the time. Then you've got, because this is equilateral, this will have to be 60 degrees. All the angles of an equilateral triangle are 60, which means that the one next to that is 120. But now this becomes isosceles, ABC, and therefore these two angles, the other two angles of this triangle ABC are both equal, because CA is equal to CB, but they add up to 60 degrees, so each must be 30. They're both equal, so they must be each 30 degrees. And that is the question that was asked. What is the size of angle ABC? The next question that is asked is, what is the area of the shaded region? So if that is 30, just watch this. So this is 30. Remember, this is 60. So we have that this angle here, BAD, is 90 degrees. So this angle is 90 degrees. Let's have a look at the question now. Find the area of the shaded region. Now this shaded region, it's actually, if you call it A, say X, and then the other, this is a part of the circle, DAC. Now I'm including the shaded region has got a curved side, right? So you got X is that part and Y is this part. Okay. Now you need to calculate X. But I can see that I can calculate X plus Y. It's a right angle triangle. We know all the sides, so let's just get this thing right. So this is 1. So in this right angle triangle here, I can calculate its area, the area of ABD, area of triangle ABD, ABD. And that'll be half base times height. Let's take the base to be 1. Take this to be base. That becomes the height. Now, all these are 1. So, therefore, in this right angle triangle, you have that the hypotenuse is 2. The other side is 1. So, the third side will be square root of 2 squared minus 1 squared. That's by Pythagoras. So it's 4 minus 1, which is 3. So the third side is square root of 3. That's half base times height. And that is just root 3 over 2. Okay, so why did I find the area of ABD? So, because then I can subtract from it shaded area equals root 3 over 2. That's the entire area minus the sector. I'm not sure what the name of that is. I'll put it in inverted commas, sector ADC. It's got a curved boundary. So when you take this thing out from the triangle, you'll get the yellow part. So that's what we're looking for. Now, what about this sector AD? Do we know the area of that? Well, remember, when I joined that before, this was a nice this equilateral triangle. So this angle here is 60 degrees. All right, so the area of that is a piece of a circle, like it's a pizza piece from a, and this is 60 degrees. So the area of the sector Because this is 60 degrees, it's the fraction of 360. This is 60, so there's 360 right round. So the area of this is just 1/6 or 60 over 60 of area of circle. And the area of the whole circle, and this one here, it just cuts off 60 degrees, so it has to be 60 over 360, which is 1/6. And that is 1/6. The area of the circle is pi r squared. R is 1. So this is pi over 6. So this tells you that the area, the shaded area that you're looking for, is equal to the area of the whole triangle, which is square root of 3 over 2 minus pi over 6. The whole thing is root 3 over 2. This part is pi over 6. So this is your shaded area. The nice, beautiful colors. I love this blue. I always use black, but this is a nice color. All right, so that takes care of question 7. And it's root 3 over 2 minus pi over 6. So let's just clear all these drawings and go to the actual solution. And you will see all this calculation. And right at the end, at the bottom, you'll see you got root 3 over 2 minus pi over 6. So that confirms that what we have been doing is quite correct. Okay, so now let's get on to question 8. Question 8, I wouldn't read all this. I will just tell you that in this diagram here, you got triangles having this size. Let's see, it's red. If you look at that triangle, there are 4 such triangles. Okay, the one has got this as a vertex. Then you have another one which has got this as vertex, going down there like that. And then you got one which has got this as vertex. So this becomes a base. I think it's better to say this is the base, that's the base, these two, and that's the base. That gives you 3 triangles. And there is one which is upside down. There are 4 triangles. This one here is upside down. Okay, so you've got 4 triangles of that type which I've been just talking about. And I'm not reading this, but I'll tell you what it says. It's got 10 small triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 small triangles, and these 10 triangles are filled with numbers. See, some of the numbers are shown 2, 4, 7, 5, and 7. But the numbers are the 10, all the 10 numbers from 1 to up to 10 are used up here. Right? You already got 2, 5, 4, 5, and 7. And so you can imagine what the question will be. Okay, actually, the question is find the middle number. Wait a minute. Find what are the possible values? Looks as if there's more than one value. For the middle number in the lowest line of the figure. So the lowest line is that, and the middle number is that. So just bear in mind that I need to calculate that number. Sorry, that looks like a 7. So we need to calculate this one here. All right. Okay, so you have to put all the numbers from 1 to 10. We're going to need to put 6 more numbers to, yeah. But now the other useful thing is, they say that, these triangles, which I spoke about earlier, each one of them has got 4 small triangles. 1, 2, 3, 4. And they say that the sum of those 4 numbers in each of those 4 triangles is the same. And when you add these 4, you get a certain answer. When you add these 4, you get the same answer. When you add the middle one, you get the same answer. And when you add the bottom one, you get the same answer. So that's a very important and useful fact. That should help me to get the answer to this question. Okay, I've drawn those 2 triangles here again. So let's see, how are we going to do this? Well, one of the things that I can say is that the sum of all the numbers all 10 numbers is, they're consecutive numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know the formula for that. It's n into n plus 1 over 2. The sum of the first n counting numbers is n into n plus 1 over 2. Counting or natural numbers, same thing. All Olympiad students should know that, and you are in round 3. So that's it works out to 55. All right. Now, we also know that this triangle, let's call this X, the middle one. Right. You'll have that okay, let's do it this way. Take those 3, and those 3. Right? Each of those, they share the angle X. This is in that, it's in that, it's in that. Right? And the sum is all the same. So it means that if you remove the X, right? Like in this sum, if you remove the X, it will be the same as the sum of these 3. Let's put it this way. The sum of these 3 plus X is the same as the sum of these 3 plus X. So the X's cancel. So the sum of these 3 equals the sum of these 3. Let's call this Y. The sum of those 3. So this will also be Y. And likewise, this is also Y. So these 3 plus X is the same as those 3 plus X. So you can say all of them are Y. All right, so therefore you got 55, the sum of the whole lot. You got there's 3 here, there's 3 here, there's 3 here. That makes 9. So it's the middle one plus 3y. Because it's y plus y plus y. That gives you, covers up 9 squares together with the x. That gives you 10 squares, and you've got that. Okay, so we can say 3y is equal to 55 minus x. Now what does this mean? It means that this thing here is a multiple of 3, right? So what are the possible values for x? X can't be 1. Oh, wait a minute, x can be 1. Because 55 minus 1 is 54. And 54, the sum of the two is 9. So it's a multiple of 3. This quantity here is a multiple of 3. And we know the rule for the multiple of 3. You add the digits and see whether it is multiple of 3. So when n is equal to 1, it works. When n equals 4, 7, and 10. You can try all these. They all change by 3. 3 more. So if you take 10, for instance, 55 minus 10 is 45. 4 plus 5 is 9. So that's, but any other number, it doesn't work. All right, so x is going to be one of these 4 numbers. But watch, 4 and 7 are already in. Right. So x, the no number is repeated because all those 10 numbers are used up. So this means that 4 and 7 are used up. So we can't include 4 and 7. So there are 2 possibilities for x. X is 1 or 10. So let's try x is 1. So suppose that number is 1. Now, look, if x is 1, then 3y is equal to 55 minus 1, which is 54. And this is a multiple of 3. So y is 18. So these 3 numbers add up to 18. You already got 7 plus 2, 9. So this has to be 9. Right. But not only that, now you see if I put this 9 here, the triangle, the entire triangle adds up to 19 because you got 1 plus 9 is 10 plus 2, 2 plus 7, 10 plus 9 is 19. So all these triangles, the sum of the 4 numbers is 19. Right. Okay, let's have a look at, for instance, we'll call these 2. Call it P and Q. Right? P and Q. P is that one, and Q is that one. All right, now you've got those 4 numbers add up to, what did we say, 19. 2 of them add up to 9, 10. 9 plus 1. Therefore, P plus Q. The whole 4 add up to 19. And 2 of those 4 add to 10, 1 plus 9. So the remaining 2 will sum to 9. So you got P plus Q is 9. I'm going to unshade this thing. Right. Now, if they add up to 9, that's easy to see which numbers add up to 9. You can have 1 plus 8. Actually, you can't have 1 plus 8 because 1 is already taken. You could have 2 plus 7. You can't take that as well because both of them are taken. You could have 3 plus 6 or 4 plus 5. But 4 plus 5 is out. So this is 3 plus 6. So this could be 3 and this could be 6. Or it could be 6 and 3, right? Now, so in this case here, the 3 numbers here add up to 18. So these three will have to add up to 18 because this 3 is the same as the sum of these three. 5 plus 6 is 11. Then this has to be 7. That's not allowed because 7 is already taken. So 6 can't go here. See, all this is just very logical. You try and you say, well, and eliminate. Okay, if I put 6 here, then I'm going to have 7 is going to be repeated. So I'll have to put the I chose them as 3 and 6. Now I have to choose them as 6 and 3. Okay, now remember those three numbers that add up to 18. So 5 plus 3 is 8, and the 10 falls, yeah? And these four numbers add up to 19. Or otherwise, 4 plus 6 is 10, and they add up to 18. Oh, that's fine. So you got the whole 10 numbers there, and you can check to see that the uh, the conditions are satisfied. You got the same sum for all four numbers. All right. So that just takes care of one. The question says that there are two such situations. We found one. Let's get to the next one. Yeah, x was 10. We said that the middle number is either 1 or 10. And then if x is 10, then 3y is 55 minus 10, which is 45. So y must be 15. So in this case here, the sum of these three is 15, and the sum of the four will be 25, right? Because x, yeah. So 7 plus 2 is 9. So this has to be 16, 6. So the sum of these four numbers is 25. 10, 18 plus 7 is 25. Okay. So again, we do the same thing as we did before. And we call these, take this the square here, call it P, call that Q. So these four numbers add up to 25, because we've just got these four numbers here. All the four numbers are the same. So you got, in this case, you got P plus Q is 10 plus 6 is 16, and 25. P plus Q is still 9. Even in this case. All right. So again, but this time you're going to have 1 plus 8 is a possibility. P and Q could be 1 and 8. 2 plus 7 is out. 3 plus 6 is out because the 6 is here. And 4 plus 5 is out. So there's only one way in which you can fill these two squares, and that is 1 plus 8. So you could have a 1 here and 8 here. And remember, they add up to 25. So 10 plus 8 is 18 plus 5 is 23. So this gives you 2. And this is 5 and 10 is 15. 5 and 4 plus 1 is 5, plus 10 is 15. And this is 10. Oh, in fact, this 2 doesn't work. So you can't put 8 and 1. You'll have to put 1 and 8. 8 and 1 doesn't work. So what did I put? Was it 8 here? Yeah, when I put 1, 8 like that. Then you got 10 plus 6 is 16. So this has to be 9 and 8, 18 and what? 11, 20, 25, 12, oh, this is 3. 12 plus 10 is 22. 3, so no, that's fine. No number is repeated. So these are the two solutions. Okay? All right. And in here, I've written the solution in full, and I've argued it out. The arguments might not be the same, but you'll see that you get the same answer. The answers are put in the extreme right there. Right. All right, let's get on to the next problem, which is question 9. It says here that find 3 pairs of integers m and n, where m is greater or equal to n, such that 1 over m plus 1 over n equals 1 over 5. The integers. All right, m could be equal to n, and you'll see that 1 over 10 plus 1 over 10 is 2 over 10. So mn equal to 10, 10 is a solution. You can see that by inspection. So, but now you need to find 3 pairs. So there are 2 others which are not necessarily obvious. Okay, so how do you solve a problem like this? Well, the idea is to find one of the unknowns in terms of the other, because you've got 2 unknowns. So make one of the unknowns a subject. So I can take, for instance, I can take 1 over m. 1 over m is equal to 1 over 5 minus 1 over n. Okay, so I can bring it to the other side, and I can simplify this to get 5n, and you get n minus 5, right? That's 1 over m. So if you invert it, you'll have 5n over n minus 5. So the first step is to find m in terms of n. Now you can make various substitutions for n and try to see whether that will give you an integer. You need to have integers, see? Well, n seems to be greater than 5, so maybe you can try n equals 6. N equals 6 works. So 6 minus 5 is 1, 6. So you get 30 over 1. So by inspection, you can see n equals 6. In which case, 6 minus 5 is 1. 6 times 5 is 30. And then m is 30. Right, so if you make 1 over 30 plus 1 over 6, you're going to get 1 over 5. All right. And then when you try the next one, you try 7, you get 35 over 2. It doesn't work. 8, 40 over 3. Doesn't work because those are not integers. All right, there is still one more. Now, how do you find that one more? There's a trick here. What you do is, in all these problems, you see this n minus 5, which is at the bottom, try to get it into the top. I got a 5 here. So if I put a 5 in front, then I get my 5n. And so, but now this is 5n minus 30 over n minus 5. And I'm sorry, 5n minus 25. But you got 5n here. You have to make the adjustment. To make the adjustment, you had to add 25. You got minus 25 here. Add 25, then this becomes equal. Now, why is this nice? Because you have A over C plus B over C equals A plus B over C. And conversely, when you got A plus B over C, it's the same as A over C plus B over C. So here you got 5 into n minus 5 over n minus 5 plus 25 over n minus 5. This over that plus that over that. Now, this is where it becomes clear why you have to put n minus 5 there, because it cancels. Right? Now, you want m to be an integer. You already got 5 as an integer. So therefore, this thing here is an integer. Now you might say, well, we came back to the same problem. Not quite. Because for this to be an integer, you got a single number here. It means that n minus 5 is a factor of 25. That's the only way you can have this to be an integer. N minus 5 is a factor of 25. Right. And so you list all the factors of 25. 1 is certainly a factor, 5 is a factor, and there's only one other factor, and that is 25. It's 5 squared. 5 is a prime number. So you don't have any other factors. If that is n minus 5, then n, you have to add 5 to each of these solutions. You got 6. To get n, you have to add 5. N minus 5 equals 1. Bring 5 to the other side, you're adding 5. Add 5, add 5. Right? So you've got your mn is 1, 6, 5, 10, and 25, 30. No, 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 no. I'm sorry. When n is equal to 6, you have to work out what m is. Okay, I've got n is equal to 6. So let's put the second coordinate to be 6, second coordinate to be 10, the second one to be 25, 30. So these are the three first we're looking for. When n is equal to 6, you go to this equation here. When n is 6, 6 minus 5 is 1, 25 over 1. Oh, we saw this before. 25 over 1 is 25, and this becomes 30. When n is equal to 10, 10 minus 5 is 5. 5 goes in 25 5 times. So you get 5 plus 5 is 10. And when n is 30, you got 30 minus 5 is 25. 25 plus, over 25 is 1. And 1 plus 5 is 6. So the solutions are 36. You see, we had 36, we had 10, 10. And the other one that we didn't get was 630. Right? But this calculation tells you what that is. So this method here will give you all the solutions all the time. And it's a very good method. You the crucial part is this part here, where you create your denominator in the numerator so that you can cancel. And then the problem becomes easier because all you have to do is look for the factors of 25. See, you can't do that. You can't speak over the factors of 5n, right? You don't know what n is, so what's the factors of 5n? But you can say what the factors of 25 are. All right, so that takes care of that problem. And So there it is, right at the bottom there, you can see it's the same solutions that I had. Okay, let's go to question 10. This looks like an arrow here. A square with side length 2 is inside a square with side length 7. Okay, you can see that the two white squares. This large one, that's a square of side 7. And you got a square of side length 2. So all these are 2 here. Right. And then what happens is the 4 vertices, or the 2 vertices, are joined to this one, and the same 2 are joined to that one. So you got this picture here. The sides of the smaller square are parallel to the large one. So this is adjusted so that that is parallel to that. It's not tilted. This little square is not tilted. Okay, so the question is, show that the area of the shaded region does not depend on the position of the small square. So what does that mean? It means that it doesn't, wherever you put your small square, I can put it there, and then I can work out in this case here, I will join, I'll take this point and this point, now join it. So you got like that, and then so if you join oh actually, sorry, this thing here is like this. You see, these 2 dots, let me just put these 2 dots, which are opposite each other. So I put the dots here and the dots here. This dot here is joined to that and that, which I have done. And the one opposite it, this one here, is joined to the same 2. Like that. Oh yeah, and this is fine. But so they say that this, if I shade this region here now, and this, right, that shaded region, the sum of these 2 is still the same. It doesn't really matter where this little square is, right? You can have it anywhere in this, inside here, and draw the same picture. Take these 2 dots, which are opposite each other, and join them to these vertices. You'll see that the areas, you have to show that the areas are the same. So let me not draw another one, but I'll try to calculate the area. It seems that I can actually calculate the area to be a fixed number, right? Although we don't say where the square is. Okay, so how do I calculate the area? Well, this is a rather strange shape, but I can break it up into triangles. like that, I can break it up into 4 triangles. So then once I break it up into 4 triangles, then I can work out the area of each triangle and sum them. And that will give me the area of the shaded region. So that gives me an idea of how to tackle this problem. Let's start with this triangle here. Right? Now we know the base is 2. Okay, so what is the height? To work out the height of the triangle, I have to draw the height from this point to this line. But I might as well take it like that. From here, I drop a perpendicular. Right? And this becomes the height. Let's give a name to this. Let's call it A. So the area of this triangle here is half base, which is 2, half of 2, which is 1, times the height. The height is the distance from this point to this parallel line. So it's the same as the distance between these two parallel lines. We're going to call it A. All right, so that's the height of that triangle. With this triangle here, we can take this to be the height. Because it's the distance from this point to this parallel line, right? And you can take any point on this parallel line, work out the distance. So this becomes the height. Let's call this height here B. Right now I'm going to calculate the height of this third one. And you see, as before, the height is this one. Let's call it C. And finally, the height of this triangle is this distance. So it's the distance from this point to this line here, which is this distance, that's the last one. So that will be equal to 4, D. Okay, so we've got 4 unknowns here now, so that's the problem. It looks as if the area that we're going to calculate depends on these 4 unknowns. So, and then it'll matter where we put the square. But we were asked to show, no matter what these unknowns are, we'll always get the same answer. So let's work out the area. Shaded area. The way we constructed it is half. Let's start with that one there. It's half base, which is all the bases are the same, times the height, which is A. All right. And the second one will be half base times B. The third one is half base times C. The fourth one is half base times D, because in all the cases, the bases are the same and the heights change from A, B, C, D. Right. Half of 2 is 1, so this is equal to A plus B plus C plus D. Now, if you look at A plus C, let's put those together. A plus C plus B plus D. A plus C is that length plus that length. And if you add 2 to it, you're going to get 7. So A plus 2 plus C is 7. A, all vertically downwards, you see. A plus 2. If you don't understand that, all you have to do is to just draw another line here. Extend this. And then you will see that you got a rectangle here. So this part is C. Now you can see A plus 2 plus C is 7. Right. So therefore A plus C is equal to 5. So this A plus C is 5. And in a similar way, B plus D, that plus that is also 5. Yeah, so the area that we're looking for, shaded area, is 10. Right? The A's, B's, C's, and D's don't play a role in the calculation of the area. So it doesn't really matter where the square is, you're going to get the area is going to be equal to 10. Okay. So I'll just show you my solution. Yeah, so you see right at the bottom, so the area is always 10, regardless of the situation of the small square. Okay, it's exactly the same solution that I had, that I had worked out earlier. Okay, so let's just get on to the next problem, which is question 11. Upon this problem, it's a very nice problem, I thought. Right, let's look at it. What is the remainder when 7 to the power of 2001 or 2021? This paper was written in 2021, and that is divided by 6. When you divide 7 by 6, you get 1. You take 7 to the power of n equals 1. That means 7 divided by 6, the remainder is 1. 6 goes into 7 one time, the remainder is 1. When n is equal to 2, you got 7 squared, which is 49. And 49 divided by 6 is 8. 48, remainder 1 again. N equals 3. 7 cubed is 343. When you divide by 6, 6 goes in 34 5 times. 43, 6 goes in 43 7 times. 7 6s are 42. The remainder is 1. So it looks as if the remainder is always going to be a 1. Right? No matter what the power is. 7 to the 1, 7 squared, 7 cubed. Right? So in a competition, you can say, well, by looking at the pattern, the remainder is going to be a 1. And write down the answer, you'll get full marks. But in round 3, you are asked to explain everything. So if you write down the remainder is 1 and there's 7 marks for it, you'll get 1 mark. To get that remaining 6, you have to explain why you get that. Okay, so I'm going to look at this. But you could, the power is very, very big. You can't multiply this, obviously. No computer will be able to calculate this. The reason being it's got a very large number of digits. All right. I think it's got over 16,000 digits, this one. All right. Now you just say, okay, what is this? We've seen this. In our school maths, we've seen 7 to the n. Where do we see it? If you think of n as the exponent and 7 as a common ratio, we had a formula which is r to the power of n in some formula, and that formula occurred in geometric progressions, the sum of a geometric sequence. There was an r to the n. That formula occurred there. So, and actually, that it's a sum of n consecutive terms of a geometric series. The formula is a to the power of r to the power of n minus 1 over r minus 1. This is the sum, S subscript n. Right? R is a ratio, A is the first term, and n is the exponent. So if I take that, now remember on the left hand side you got 1 plus r squared. Okay, I'm not going to, I'm going to let a be equal to 1. 1 plus r squared, all to the r to the n minus 1. To make n terms, yeah, you got 1, 2, you can count from here, 1, 2 up to n minus 1. That is why you've already got a starting point here. There's 1 here. So the terms here are 1, here it's 2, here it's 3. So when the index is 2, you got 3 terms. So if you want the index to be, the number of terms to be n, this has to be that. So this is equal to, a is 1, so it's r to the n minus 1 over r minus 1. And what I want is 7 to the power of 2021 minus 1 over 7 minus 1. Right. And I've actually put the n to be 2021 because that's what was asked. 7 to the 2021 and r is 7. So on the left-hand side, I would have had 1 plus 7 squared, 7 to the power of 2020. This gives you n terms. Right. Let's call this x. This monster of a number, we'll call it x. Right. Now you'll see how beautifully it works out because you got 7 to the power of 2021 minus 1 over 6. 7 minus 1 is 6, is equal to x. So when you multiply both sides by 6, you get 6x equals this, and 7 to the power of 2021, is that's what we're looking for, is 6x plus 1. Now, this 6x plus 1 means that when you divide by 6, the remainder is 1. And I think that was the question. What is the remainder when this is divided by 6? Right, so you see how the 6 just automatically features here. Right. Now 6x plus 1. The remainder, this one, the 6x plus 1, I think I should say this. If you take any number of the form 6x plus 1, x must be a positive integer though. Right? We normally use n for integers, say 6n plus 1. This You see, when you're dividing a number n by 6, you get a quotient and you get a remainder. So let's say you take a number m and you divide by 6, you get a quotient and a remainder. Then you'll notice the original number m minus 1. This is the remainder. So if you subtract it, that will be equal to 6 times n. So m is equal to 6n plus 1. I want you to understand what I'm doing here. What I'm saying is that whenever you got a number of this form, it means that if you call it m, there it is. It means when you take this number and divide by 6, as I've done, take this number and divide by 6, the quotient is n, and the remainder is 1. And if you substitute the various values for n equals 1, you'll have 7, 13, and so on. You will see that all these numbers, when you divide by 6, the remainder is 1. Okay, so that answers the first question. First question was, what is the remainder when 7 to the power of 2021? There's it. When you divide by 6, what's the remainder? And this equation tells you that the remainder is 1. Okay, then you got the second question. Oh. The part B says n is equal to, now you start with 7 and land up with 2021. And the question is, what are the last 2 digits of n? 6n. Okay, let's use a space. You got n is equal to 7 plus 7 squared to this, and it goes up to 7 to the power of 2021. And they want to know what are the last 2 digits of n. Okay, you can't see what the last 2 digits are here because you've got so many numbers which are added, and when you add up the whole lot, and then you have to look at the last 2 digits. I mean, it's a huge number. I think I told you it's got over 16,000 digits in it. So it looks as if this task is impossible. But, the last 2 digits of not n, but 6n. It's 6n. Now, you'll notice here that you can get 6n from n. And one of the ways is multiply n by 7 and then subtract 6n minus n. So let's multiply this by 7. 7 times 7 is 7 squared. I'm going to put this 7 squared underneath the old 7 squared. So it's 7 times 7 plus 7 cubed, and so on. And you'll have 7 to the power of 2021, but this last number is being multiplied by 7. So you have 2022. So that's 7n. Now, why is this interesting? Because you see, your n, you subtract these two. And then when you do that, you got the n is equal to 7n minus 6n is n. All right, so you have to take this 7, there's no 7 here. So you have to keep the 7 down. But these subtract 7 squared minus 7 squared, 7 cubed minus 7 cubed. This, well, actually, you're subtracting this way, sorry. 7n minus n. So I'm supposed to have minus 7 there. So you subtract, and you'll get that 6n, this minus this, and a minus 7 here. And then there's only one other term. There's 7 to the power of 2002. Okay, so we need to find the last 2 digits of this. This is very much easier. You haven't got all those billions of numbers to add. So it's just an ordinary subtraction sum. Okay, so we'll look at the last 2 digits of 7 to the n. Let's examine that. Okay, we can put down, let me do it here in the side. So if you put n equals 1, 2, 3, 4. All right, so give different values for n. So we need to work out 6n. No, you're working on 7 to the power of n. Okay, 7 to the power of 1 is 7. 7 squared is 49. And 7 cubed is 343. Somebody shouted out that earlier on. So 7 cubed is 343. So the last 2 digits are 43. Now, when you multiply 7 to the power of 4, you have to multiply these two, and you'll get 301. So you get 1 now. And that's a very nice number. So if you multiply this by 7, you'll have 0, 7. That's the ending now. The next one you multiply by 7, you get 49, 43, and you get 0, 1. 43 times 7 is 301. So you see that 7 to the 4 is the same as 7 to the 8. In fact, every time you come to a multiple of 4, you must land in 1, 0, 1. The same numbers keep repeating. Once you comes to 1, then you have to keep multiplying by 7. You'll get exactly the same as the first 4 numbers. So where was I? Yeah. Right. So what does this mean? It means that when you got a multiple of 4, the ending is 0, 1. All right. Now I want to get to 7 to the power of 2022. Now, this is not a multiple of 4, unfortunately. 2022. But 2020 is. You can see 4 goes into the last 2 digits 5 times. In 2022, it doesn't. But we know the last 2 digits of 7 to the power of 2020 is 0, 1. Just like 7 to the 4. Right? We said the ending is 0, 1. So of this is 0, 1. So if you got 2020, right, the last two digits is 0, 1. We want to get to 2022, shall we? Or 2021? Oh, yeah. Yeah. I really need to calculate this thing here. So let's take 7 to the power of 2021. So you have to multiply this by 7. And 7 to the power of 2022, you multiply this by 7. Wow. So we've got the last two digits of so you've got this. So 7 to the power of 2022 minus 7 minus a long number, and the last two digits are 49. All right? And you're subtracting 7 from that. And now you can see quite clearly that the last two digits are 42. You can actually subtract because 7 is just by itself. If you subtract here, you get 42. So that's the answer to that question. All right, let's have a look at the answer that I got. Okay, the first part, the remainder is 1. And then so you can see right at the bottom, the last two digits are 42. So you can always come back to this page and study it in case you didn't understand before. All right.